Hi, Mr Wright here, and welcome to this film in which we'll work our way through the Edexcel IGCSE paper 2H from summer 2024. First things first, if you're preparing for your Edexcel IGCSE maths exams, please hit like now and let me know that you're watching. Now, you can download the questions by clicking the link in the description, and then you can work your way through the paper and then watch the film, or you can watch the film as you work your way through the paper and work alongside me. If you've got any questions, any comments as you watch the film, please leave them in the comments, and of course I'll respond. If you're looking for any resources on any particular topic, tell me in the comments, and of course I'll help you out as well. Before we start the maths, please, if you haven't already, if you're preparing for your Edexcel IGCSE maths exam, please hit like now. Right, let's get on with the maths. Okay, question number 1. Now, I'm looking at this and I'm thinking that we've got 8 numbers written in order of size, and we're given some information here about their median, their mode, and their range. So this is obviously a question on mean, mode, range, and median. Now let's have a look at this. We've got 8 numbers. We've got a mystery there, a mystery here, a mystery here, and a mystery here. The numbers are written in order of size. Now my first clue here is that the median of the 8 numbers is 10. Now remember, the median is the middle number when they're written in order of size, and in this case we've got 8 numbers. So the median is halfway between those 2 middle numbers. So halfway between there is 10. So if I've got 8, 9, 10, then it must be 11, 12. So J must be 12, because then 10 is the median. So I'm going to write a 12 here now. Let's have a look at the next clue here. The mode of the 8 numbers is 18, so there must be more 18s than any other number. So in fact, both of these, the K must be equal to 18, mustn't it? Because then there are 2 18s, which is more than any other number. Now next, the range of the 8 numbers is 13. Now the range is the difference between the highest and the lowest of those numbers. So the difference between the H and the 18 is 13. So H must be 5. And that is the value of H, J, and K, and that is question 1 complete. Let's move on. Question 2. Now it's asking me to draw some straight lines and then do some shading. So this is representing inequalities on a grid, isn't it? It's linear programming, it's called. Let's have a look. On the grid, draw the straight line with the equation y equals 2. Well, that's the line that crosses the y-axis at 2. See how it tells me to label each line? Y equals 2. Now, the line x equals 6 is the line that crosses the x-axis at 6. So there it is, x equals 6. And lastly, the line y equals x plus 1. Now, lots of ways of doing this. You might use y equals mx plus c, or you could use a quick table of values, which of course you could do on your calculator if you wanted to. I'm going to use a table of values. X can mean 0, 1, and 2. So if x is 0, then y is 0 plus 1. If x is 1, then y is 1 plus 1. And if x is 2, then y is 2 plus 1. So I've got 3 points there, the point 0, 1, the point 1, 2, and the point 2, 3. So there we go. That's going to be the line y equals x plus 1. Okay, so I've done part A. Part B. Show by shading on the grid the region that satisfies all of these inequalities. Well, I need y to be greater than or equal to 2. So I'm going to need to be above this red line. I need x to be less than or equal to 6. So I'm going to need to be to the left of that. And I need y to be less than or equal to x plus 1. So I'll need to be below that line. So it says show by shading. Okay, so that is the area that satisfies all three inequalities. Label the region R. Right, well, we better do what it says, haven't we? I managed to delete a line. I'm just going to put it back. There it is. Label the region R. Right, so this is the region R. There we are. That's the region labelled. And that's question 2 complete. Question 3. Now let's have a look at this. This looks to me as if it is a distance, speed, time question. So I'm going to have to remember that Dad's a saint. There's my distance, speed, time formula triangle. A plane takes 9 hours 36 minutes to fly from New Delhi to Perth. The plane flies at an average speed of 820 kilometers per hour. Work out the total distance. Well, to work out distance, looking at my formula triangle, I'm going to need to do speed times time. Now my speed is 820 kilometers per hour. And my time, now how many hours is this time? The time is 9 hours and 36 minutes. Now I need to write that in hours. It's going to be 9 hours and 36 60ths of an hour. And I can put that into my calculator if I want to. 36 divided by 60. That's 9 and 3/5 of an hour. So I'm going to do 820, which is the number of kilometers my plane goes every hour, multiplied by 9.6, or 9 and 3/5, the number of hours it travels for. So 820 times by 9.6 tells me that it travels a total distance of 7,872 kilometers. And that is question 3 done. Question 4. This looks like it's a question about mixed numbers, about multiplying mixed numbers. Let's have a look. It wants me to show that this equals 8. So what I'm going to have to do is I'm going to have to start with the calculation on the left. I'm going to need to do that calculation and show that it comes to 8. Now I'm multiplying mixed numbers here, so the first thing I'm going to do is to make each of them top heavy. 2 times 7 is 14, plus the 4, that's 18 over 7. You can use your calculator to do this, by the way. 3 9s are 27, plus 1 is 28 over 9. Now I know I can cancel here to make things easier, but because I'm able to use a calculator, I'm simply going to go 18 times 28, top times top, is 504, over 7 times 9 is 63. And now into my calculator, I'm going to write 504 divided by 63, and that gives me the answer 8. So I have shown that the left-hand side does indeed equal 8, and that's question 4 done. Question 5. Now I haven't read the question yet, but I'm looking at this diagram, and I'm seeing a right-angled triangle, so I'm thinking Pythagoras, or I'm thinking trigonometry. And looking at this, I'm only given one of the side lengths, aren't I? So this is going to be a question involving trigonometry, or involving SOHCAHTOA. So now let's have a look at the question and check that we're right. The diagram shows triangle ABC. Yes, it does. Have a quick look. I've got a side length. I've got an angle. That's x. I understand the diagram. Let's read the question. Work out the value of x. Give your answer correct to 1 decimal place. Right. Well, we've already established this is a SOHCAHTOA question. Now this side here is the hypotenuse. And given that the angle's 34 there, the x is the opposite. Right. Now, I don't know how you work out whether you're going to use SOHCAHTOA. I say which side is not involved. The adjacent is not involved. So I'm going to use SO because that also doesn't involve the adjacent. So I'm using this formula triangle here, and I'm asked to find the opposite. So I cover up the O, and that tells me that the opposite, x, equals sine the angle times the hypotenuse. There we go. So on my calculator, I'm going to go sine 34. Remember to close that bracket on the sine, times 6.5 gives me 3.6347, and so on. And I'm asked to give my answer to one decimal place. Is it 3.6 or 3.7? 3.6. And that's question 5 done. Question 6. Now, what's this question going to be about? Change a speed of w meters per second to a speed in kilometers per hour. So this is a question about converting a compound measure. I have to convert w meters per second into a speed in kilometers per hour. Let's have a look. Well, if it's w meters per second, let's do this stage by stage. Let's say if it goes w meters per second, how many meters does it go in a minute? And how many meters does it go in an hour? And then we'll worry about how many kilometers it goes in an hour. So w meters per second, well, it's going to go 60 times as far in a minute because there are 60 seconds in a minute. So it's not going to be w meters in a minute. It's going to be 60 times w. So 60 w meters every minute. And then I'll have to times that by 60 again to work out how many meters it is in an hour. So 60 times 60 times w, or 60 times 60, is 3,600. So it goes 3,600 w meters in an hour. So what about kilometers? Well, if that's the number of meters it goes in an hour, and I want to convert it to a number of kilometers, every 1,000 meters is a kilometer. So I'll have to divide that by 1,000. So 3,600 divided by 1,000 is 3.6. So my final answer is going to be 3.6 w kilometers per hour. And that's question 6. Question 7. Let's have a look at this, see if we can figure out which topic this is about. We've got a 6-sided shape. We're given some dimensions. Let's just check that each of those dimensions is labelled. AB equals FE equals 13. So I can label that one 13 as well, can't I? The perpendicular height of the shape is H. I can see that. CD, which is this line, is parallel to AF, which is that line. Okay, that's how it looks on the diagram. The area of the shape is 390 square centimeters. If I work out the value of H. So this looks like an area problem, doesn't it? And it involves this shape. And if I look at this shape, if I were to cut it off here, then I've got a rectangle on the bottom and a trapezium on the top. Okay, now if the area of the whole shape is 390, look, I could find the area of that rectangle. So the area of the rectangle is 13 times 21. 13 times 21. So the area of the rectangle is 273, which means that now I know the area of the trapezium. So here's my trapezium. There we are. Looks like this. And I know the area of this shape here. So it's going to be 390 minus 273. So the area of this trapezium is 117. And I know that that's 21 and that's 15, and that is the height of the trapezium, which I'll call x. Now, that means that a half times 15 plus 21 times x equals 117. On the left there, that's the formula for the area of the trapezium, which is on the front of your exam sheet. So this is, what's a half of 15 plus 21? Let's have a look. 15 plus 21 divided by 2. So that means that 18x equals 117. So now I can find x. 117 divided by 18. So x is 6.5. Is that the answer to the question? Let's have a look. In the question they say work out the value of h, and h is the distance. It's the whole height, isn't it? So I've worked out that this top bit here is 6.5, so the whole height must be 13 plus 6.5. So h is 13 plus 6.5. So h is 19.5 centimeters. And that is question 7 done. Question 8. Let's just pause, scan the question, see what it's all about. Or just a quick scan of the question tells me that it's going to be about ratios and percentages. Let's have a look at the question properly, shall we? Right, we're planting 600 bulbs in a garden. We're planting tulip bulbs, crocus bulbs, and daffodil bulbs. And the ratio of the number of tulip to the number of crocus, the number of daffodils, is 9 to 4 to 2. Let's give ourselves a total there, and the total of our ratios is 15. Oh, now just a minute. We know that we're planting 600 bulbs in total, don't we? So if I write the 600 in my total column there, I can work out what my multiplying factor is. So 600 divided by 15, I'm multiplying by 40 here. So I can do 9 times 40, 4 times 40, and 2 times 40 to work out how many of each type of bulb we're planting. 9 times 40, 360 tulip. 4 times 40, 160 crocus. 2 times 40, 80 daffodil. And then I could just check that these three numbers do add up to 600. Okay, now I know how many of each sort of bulb I'm planting. Let's carry on reading the question, shall we? 45% of the tulip bulbs are yellow. 3/8 of the crocus bulbs are yellow. All of the daffodil bulbs are yellow. Work out the total number of bulbs that are yellow. Right, so let's have a look. So the yellow ones are going to be 45% of the tulip. So that's 45% of 360. Plus 5/8 of the crocus. So 5/8. Oops, I wrote 5/6. So 5/8 of the crocus. So that's 5/8 of 160. And all the daffodil. So that's plus another 80. So that's going to tell me how many are yellow, isn't it? So let's work that out, shall we? Now, 45% of 360, that's 0.45 times 360, plus 5/8 of 160. On my calculator, I'm using the fraction function. 5/8 times 160 plus the 80 gives me a total of 342 bulbs that are for yellow flowers. And that's question 8 done. Question 9. Now let's have a look. Can we figure out what this question is about? This is a question about compound interest. Right, we're investing 4,500 somethings in a saving account for 4 years, and we get that much interest. Work out how much money we'll have at the end of the 4 years. give your answer correct to the nearest something. Bonus point for anyone who tells me in the comments which country uses that currency. Okay, now I've got a fixed way of doing this, so I'm going to start with the original. Now my multiplying factor, if I'm increasing by 2.4%, is 1 point the increase. So 1.024, and I'm going to multiply by 1.024 4 times, because it's in the savings account for 4 years. So into my calculator goes 4,500 multiplied by 1.024 to the power of 4. Gives me 4,947.80 and so on. Corona. Is it just Corona? Did I put that to the nearest, whatever it's called, 4,948. And that is question 9 done. Question 10. Simultaneous equations. Okay. Now, what I'm doing with these two linear simultaneous equations is I'm going to make the x's equal and then subtract. So I'm going to keep the top equation as it is, and I'm going to multiply the bottom equation by 2. So here's the top equation, 6x plus 4y equals 1. And the bottom equation I'm going to multiply by 2, because then we'll have the same number of x's in both equations. 6x plus 10y equals 16. Now I'm going to subtract the equation. So I'm going to write minus, minus, minus. And I'm going to do the top equation, subtract the bottom. 6x, take away 6x is nothing. 4y, take away 10y is minus 6y. 1 minus 16 is minus 15. Of course, you can use your calculator as much as you like while you're doing this. I'm going to now do minus 15 divided by minus 6, which tells me that y is 2.5. Right, I'm copying down the first equation, 6x plus 4y equals 1, and I'm going to substitute in this y is 2.5 in here instead of y. 6x plus 4 times 2.5 equals 1. 6x plus 10 equals 1. Subtract 10 from both sides. 6x equals 1 minus 10 is minus 9. Divide both sides by 6, and x is minus 1.5. So my answers are x equals minus 1.5 and y equals 2.5. And that's question 10 done. Question 11. Now, it looks like in part 1, I'm asked to factorize a quadratic, and in part 2, I'm going to solve a quadratic equation. Let's have a look. First of all, I've got to factorize this quadratic. So I know it's going to go into 2 brackets. Each bracket's going to be an x and an x. Now, my two numbers need to multiply to a negative, so they have to be one positive, one negative. So multiplies to 22, but then I'm going to need to end up with 9 x's. So I'm thinking 1 and 22. I'm thinking 2 and 11. Oh, 2 and 11 is looking good. Let's try the 2 here and the 11 there. So let's have a look. Would that give me the correct number of x's? It would give me plus 2 x's minus 11 x's, which would be minus 9 x's. That's not what I want. I want plus 9 x's. So I'm going to need to have the plus 11 and the minus 2. So there is my answer. That factorised the quadratic, and there is my solution. Hence, part 2, so we're going to use our answer for part 1, solve this quadratic equation. Well, it's already set equal to 0, so I factorise the left-hand side. That's the bit I've already done. And then hence I can work out the solutions. X is going to be minus 11, because that's the value of x, which makes that expression equal to 0. Or x can be 2, because that's the value of x, which makes that expression equal to 0. And as I hope you know, we need one of those expressions to equal 0, so that their product equals 0. And that's question 11 done. Question 12. Now, what's this question about? Aha, look, we're given the number of days. For the first 4 days, the mean number of steps is 11,800. And then for the next 3 days, the mean number of steps is 13,207. And we're asked to work out his mean number of steps for all 7 days. So this is a question involving combining those means. Right, now you see how in the first 4 days, the mean is 11,800. And we know that in the next 3 days, the mean is 13,207. We're asked for the mean for the whole of the 7 days. So for the whole of the 7 days, we're going to need to know the total number of steps, and then we'll divide that by the number of days, 7. Now, these first 4 days, they have a mean of 11,800. So we know the total number of steps for the first 4 days is the number of days 4 multiplied by the mean. That's the secret of this question. And for these next 3 days, we know the total is 3, the number of days, multiplied by the mean. So we can work out the total for the first 4 days, 4 times 11,800. And that is 47,200. We can work out the total for the next 3 days, 3 times 13,207, which is 39, I'll do that in red, shall I? 39,621. So now I know his total for all 7 days, 39,621 plus 47,200 is 86,821. So the mean for the 7 days is 86,821 divided by the number of days, 7. Divided by 7 equals 12,403 is the mean number of steps for the 7 days. Question 13. Now, looking at this question, I can see that it is a question about cumulative frequency. The table gives information about the distances in kilometres that 70 teachers travel to school. Wait a moment, teachers travelling to school? I thought we all slept at school on a camp bed at the back of our classrooms. But never mind. This question is all about the distances that teachers travel to school. Take a moment, make sure we understand this table. It's telling me that 7 of the 70 teachers travel a distance between 0 and 10 kilometres, and at the other end of the scale, 4 teachers travel a distance between 50 and 60 kilometres to school. And there are lots in between, and remember, there are 70 teachers altogether. Right, let's complete the cumulative frequency table. So we know already that 7 travel between 0 and 10. So how many travel between 0 and 20? Well, this 7 and also that's 17. So that's 24. Add another 18 now. So 42 travel between 0 and 30. Add another 14, 56 in total travel between 0 and 40. Add another 10, 66. And add another 4, so that's all 70 teachers accounted for. All 70 teachers travel between 0 and 60 kilometres. On the grid opposite, draw a cumulative frequency graph for your table. Right, so remember, you're going to plot the endpoints here, the 10 against the 7. And sometimes they use a different scale on the y-axis than they do on the x. Let's have a look at the scales carefully. In this case, I don't think they've done that to us, which is kind. So we have 7 teachers who travel up to 10 kilometres. So there we go. Make sure you're using your scale correctly. 1 square on the y-axis is 1 teacher. Then 24 teachers travel up to 20 kilometres. 42 teachers travel up to 30 kilometres. 56. Okay, I'm getting the idea of this now. Just don't mess it up because it should be easy marks, I hope. And then 66. And then 70 travel there. Now, when you're joining up your cumulative frequency graph, you can draw a smooth curve between your points, or you can use your ruler and you can join each one up with a straight line. Because I'm on the screen, I'm going to do each one joined up with a straight line, which is perfectly all right. Okay, and you get your marks if you do it this way. Equally, if you prefer to draw a smooth curve through the points, then do that. Okay, there's my cumulative frequency graph. Use your graph to find an estimate for the interquartile range. Now, there are 70 teachers, aren't there? So the 35th teacher, this distance, is going to be the median distance. I'm not being asked for that, but I'm just drawing it on here so that I can just explain to you how I'm going to get the interquartile range. So that's the median, right? I'll put med here. So the interquartile range is the difference between the upper quartile and the lower quartile. Now, the lower quartile is going to be halfway to this 35. So that's going to be 17.5. So I'm going to find 17.5, okay, which is here. I'm going to draw a straight line with my ruler across here, hit the cumulative frequency curve, and then I'm going to draw a straight line down, and I'm going to read off that distance. So the lower quartile looks to me to be 16.5. Lower quartile, 16.5 kilometers. Now the upper quartile is going to be halfway between the 35 and the 70. So I'm going to do 35 plus half of 35. So 35 plus 17.5. So it's going to be the 52.5 person. So let's go up to the 52.5. Here we are. Let's draw a straight line with a ruler. From there, hit the line. And then we're going to draw a straight line down here. Oh, that didn't work. Let me try again. Come on, straight, that's it. Right, so down we go to there. So that looks to me to be, what is it, 30, 35, 36, 37, oh, 37.5. So I've got an upper quartile of 37.5. So the interquartile range is the difference between those. So I'm going to do 37.5 minus 16.5 gives me an answer of 21. Okay, now in the mark scheme, it says anything from 18 to 22 is fine, as long as you've used your graph correctly. Right, next. Use your graph to find an estimate for the number of teachers who travel more than 46 kilometers. More than 46 kilometers, so let's have a look. So here's my distance, and here's 46, right? So I can use my graph to find out how many teachers travel 46 or less by zooming up here and then moving across here. There we are. So I have got on my graph 62 teachers travel, what is it, 46? Travel 46 kilometers or less. So it's going to be the rest of them, 70 minus 62. 8 teachers travel more than 46. And in the mark scheme, it gives you your mark for anything for 6, 7, 8, or 9, again, as long as you used your cumulative frequency graph correctly. So there's question 13. Now, before we have a look at question 14, you might want to just scan this QR code with your phone or write down that link. This is a link to a page on which I put details of lots more resources that are right there ready to help you with your Edexcel IGCSE Maths. There's lots on the YouTube channel and links to that on this useful links page. There's information about my past paper club as well, and there's information about YouTube lives coming up and various other things. So perhaps have a scan of that QR code and have a look at that page. Right, let's have a look at question 14. How do I delete that? Let's get that out of the way and get this out of the way. Question 14a, expanding brackets. Let's have a look. We've got three expressions here, 3y, 2y plus 5, and y plus 7, and we're multiplying them all together. Now, it doesn't matter what order you do the multiplications in, so I'm going to copy down the 3y, and I'm going to expand those two brackets. I'm going to multiply 2y plus 5 by y plus 7. So 2y by y, 2y squared, and 2y times 7, 14y. They've been quite kind, haven't they, because there aren't any negatives here. So it's all quite straightforward. 5 times the y, 5 times the 7, plus 5y plus 35. Close the square bracket. Now I'm going to tidy up that square bracket first. 2y squared plus 19y plus 35. And now I'm going to multiply out the square bracket. 3y times 2y squared, 6y cubed. 3y times 19y, well, that's 57y squared, and 3y times by the 35, 3 35s are 105, so that's 105y. Let's just check the question. Show that this can be written in the form something y cubed plus something y squared plus something y, where the somethings are integers. I've done it, haven't I? And that's 14a complete. 14b. Right, got to solve this equation with fractions. Now, on the left-hand side, I've got two algebraic fractions here. I've got 2x plus 3 over 5 plus 6x minus 5 over 4. And then on the right-hand side, I've got 163 over 100. Well, let's write that as 1.63 to start with. Now, what I'm going to do is I'm going to take these two fractions on the left-hand side, and I'm going to write them both with a denominator of 20. So in a sense, I'm just adding these two algebraic fractions. So in order to write the first one with a denominator of 20, I'm multiplying top and bottom by 4. So that will give me 8x plus 12. And in order to write the second fraction with a denominator of 20, I'm multiplying top and bottom by 5. So that will give me 30x minus 25, and that equals 1.63. So if I were adding fractions now, I'd have everything over 20, wouldn't I? And I've got 8x plus 12 plus 30x minus 25 equals 1.63. So let's tidy up the top there, shall we? 38x minus 13 over 20 equals 1.63. Multiply both sides by 20. 1.63 times by 20. I'm going to get 38x minus 13 equals 32.6. Right, add 13 to both sides. 38x equals 45.6. Divide both sides by 38. X equals 1.2. And that is 14b complete. Right, 15a. Make G the subject. So I've got to rearrange this expression to make G the subject. Here's the original expression. E equals the square root of this. I'm just writing it down, really. Give me a chance to have a think about it. First thing I'm going to do is bust out that square root. Let's square both sides. So E squared is going to equal 7g plus 5 over 11 plus 2g. Now let's sort out that fraction. Should we multiply both sides by 11 plus 2g? So I'm going to have e squared multiplied by 11 plus 2g equals 7g plus 5. Multiply that bracket on the left. 11e squared plus 2e squared g equals 7g plus 5. Now, what am I trying to do with this? I'm trying to make g the subject. So I'm going to put everything with a g in it on one side and all the other rubbish on the other. Let's start by minusing 7g from both sides. 11e squared plus 2e squared g minus 7g equals 5. But I got all the other rubbish on the other, so I want to get rid of that 11e squared here. So I'm going to subtract 11e squared from both sides. So now I'm going to have, let's go over here, give myself some more room. So I'm subtracting 11e squared. So I'm going to have 2e squared g minus 7g equals 5 minus 11e squared. Now I've got a problem here. I want to make g the subject, but g appears twice here. So I have to make those two g's become 1. And I do that by factorising. Gives me 2e squared minus 7. And look at that. Those two g's have become 1. And now I can divide both sides by that bracket to give me g equals. So g is now the subject. And I've got 5 minus 11e squared over 2e squared plus minus 7. But you could equally have got the answer 11e squared minus 5 over 7 minus 2e squared, and that would be fine as well. So that's 15a done. 15b, a quadratic inequality. Now we're being asked to solve this inequality. I'm just going to write it down while I think about it. Now, how do we go about solving quadratic inequalities? Well, what we need to do is we need to first of all find the values of y which make 3y squared plus 4x minus 32 equal 0. We solve this equation first, and then we worry about the inequality later. Now, if I'm solving that equation, I'm either going to try and factorize the left-hand side, or I'm going to use the formula. I'm going to factorize the left-hand side, but equally, you could use the formula. Now, if I'm factorizing the left-hand side here, then I know it's got to be y and 3y to give me the 3y squared. I know the signs have to be a plus and a minus to give me this minus 32 here. And I'm thinking 8 and 4 for the 32. And 8 and 4, wait a minute. So if I put the 8 here, then that gives me 8y, and the 4, that gives me 12. 3y times 4, so that's got a difference of 4. I want it to be a plus 4, so I'm going to want to have plus the 4. I want it to be plus 4, look here, plus 4y. So I'm going to have plus 12y from the outside there and minus 8y there to give me plus 4 altogether. And so my solutions for the equation, the values of y, which make 3y squared plus 4x minus 32 equals 0, y equals 8 over 3 or minus 4. But as I say, you could have used the formula just as easily to work out those critical values of y. Now, I'm going back to the inequality now. The inequality is about the values of y, which make 3y squared plus 4y minus 32 greater than 0. So to sort this out, I'm going to picture the quadratic curve here. Now, it's a positive y squared, so it's going to be a U shape. And I know my critical values are at minus 4 and 8 over 3. So this is the graph I'm dealing with. Now, when is that graph greater than 0? Answer, it's greater than 0 here and here. So my answers to the inequality are going to be that 3y squared plus 4y minus 32 is greater than 0 when y is less than minus 4 or when y is greater than 8 over 3. And that is question B done. Question 16. Aha, Venn diagrams question. Let's have a look. 60 art students were asked if they'd like to attend workshops for knitting, photography, or embroidery. I'm guessing some of them will want to attend no workshops, some of them just one of the workshops, some of them two, and some of them perhaps all three of the workshops. Let's have a look. Of these students, 9 chose knitting, photography and embroidery. 17, 16, 20, 28, 39, and 2 chose nothing. Use this information, complete the Venn diagram. Right, let's have a look. So from the top, 9 chose knitting, photography and embroidery. Well, I can put those in straight away. There we are, 9. 17 chose knitting and photography. Now, does that mean that I can just write 17 in here? No, because if I did that, then in fact 26 of them would have chosen knitting and photography. When it says 17 chose knitting and photography, that means that 17 are here. Some of them also chose embroidery, you see. So if 17 chose knitting and photography, then 8 must have chosen knitting and photography and not embroidery, and 9 must have chosen knitting and photography and also embroidery. 16 chose photography and embroidery. So again, I'm not going to write 16 there. I'm going to write 7 here. 20 chose knitting and embroidery. So that's 11 who chose just knitting and embroidery, and another 9 who chose knitting and embroidery and also photography. 28 chose photography. Now that means that all of this must add to 28. Well, I've already got 24 in there. 9 and 7 is 16, plus another 8 is 24, which means that there must be 4 people here who did choose photography but didn't choose any of the others. 39 chose embroidery. So that means that all of this lot must add up to 39. Now I've got 27 in there so far, so that means that 12 must go there. So there are 39 altogether who chose embroidery. 2 chose none of the workshops. 2. Use this information, complete the Venn diagram to show the number of students in each subset. Have I done that? I haven't, because I haven't got the number of students there, have I? How am I going to work that out? Well, they always do this, and you have to go back to the fact that you know there are 60 altogether. So let's work out how many I've accounted for so far. I'm going to add up 8 plus 9 plus 4 plus 7 plus 12 plus 11 plus 2 and see what that comes to. I'm worried I'm doing it too quickly now. I make that 53. I'm just going to do it again. 8 and 4 is 12, plus 9, plus 7, plus 11, plus 12, plus 2. Yeah, that's 53. And so I know that therefore there are 60 altogether. So there must be 7 there. And that is the Venn diagram complete. Okay. Part B. One of these students is chosen at random. Given that the student chose photography, so wait a minute, I know that it's one of these. Given that the student chose photography, find the probability that they also chose knitting. Well, these people chose knitting and those people. So that's 17 of the how many people who chose photography? 28. So the probability that a student who chose photography also chose knitting is 17 out of 28. Next, find the number in this. Now, what does this mean? Well, that's the intersection, so that translates to and. So we've got to find the number who are in P and not in K. So to qualify, you have to be doing photography and not knitting. So photography and not knitting, that one, those are the people who do photography but don't do knitting, because these guys do photography and knitting. So that's 11 students altogether. Okay, and lastly, find the number of students who are in P or E. Let's do those first, shall we? P or E. P or E. That's these guys are all in P or E. Okay. And they also have to be, and they have to be in K as well. So which of those shaded are also in K? Those ones, and those ones. So the answer there is 28. And that is number 16 complete. Question 17, proportion. This is a question about proportion. Q is directly proportional to the square root of D. Directly proportional. Then I'm given some information, and then I'm asked to find a formula for Q in terms of D. Right, so I'm going to go fish sign equals. I'm going to go fish sign equals find K, use K. That's my phrase for this one. So Q is directly proportional to the square root of D. Fish sign, right, equals. Q equals K times the square root of D. Now, I'm going to use these red numbers now. So I know that 4.5 equals K times the square root of 324. So finding, I've done fish sign, I've done equals. So now I'm doing finding K. Square root of 324 is 18. So I've got 4.5 equals 18 times K. So K equals 4.5 divided by 18. 4.5 divided by 18 equals a quarter. So now I can rewrite this, but instead of saying Q equals K root D, I'm going to say Q equals a quarter times the square root of D. And here's the question. Find a formula for Q in terms of D, and there is my formula for Q in terms of D. Would you like details of my next YouTube Live? If so, scan that QR code on your phone and get yourself on my mailing list, because then I will write to you and tell you what's coming up on the channel. All right, let's get on with question 18. Right, question 18. This is a question about gradients of perpendicular lines. The topic's called coordinate geometry. Right, we've got a straight line P, and it has that equation. We're asked to find the gradient of the straight line that's perpendicular to P. Let's concentrate on P first, shall we? Here's the equation. Now, from that equation, I can find the gradient of P, and then I'll be able to find the gradient of the straight line that's perpendicular to P. So how do I find this equation, the gradient of this line? Well, what I'm going to do is I'm going to rearrange it and write it in the form y equals, because I know that once it's in the form y equals, then I can simply read off the gradient, because the gradient is the coefficient of the x there. So the gradient of P is minus 2/5. So how does that help me with the gradient of the line that's perpendicular to P? Well, all I have to do is take my minus 2/5, flip it, and change the sign. So it's going to become 5/2. So the gradient of the line which is perpendicular to P is 5/2, or you could say 2.5. Question 19. I can see straight away question 19 is a question about bounds. Now I've got a whole playlist of bounds questions. So if you want a link to that, leave me a comment in the comments, and of course I'll send you the link. But let's have a look at this one first. Now, we always follow the same routine. We're given C, F, and H to a certain degree of accuracy. The first thing we're going to do, try to resist thinking about anything else, is just write down each one and find the upper and the lower bound. So C is 8 to the nearest whole number. So it's going to be 8.5 upper, 7.5 lower. F is 6.62, correct 2 decimal places, 6.625, 6.615. H, 1.2 to 1 decimal place, 1.25, 1.15. Now I haven't even read the question yet, but I have already written down the upper and the lower bound of each of C, F, and H. Only now am I going to worry about what is coming next. It wants me to work out the lower bound for G. So I'm going to write down the formula for G. And then I'm not going to think about the values of C, F, and H yet. I'm just going to write that down, and I'm going to say to myself, right, they want the lower bound. So I'm going to do the lower bound of G, and I'm going to think through what I'm going to need for each of the variables. If I want this fraction to be as low as possible, I want the lowest possible numerator and the highest possible denominator. So if I'm going to have the highest possible denominator, now I have to think through what am I going to do with the F and the H. We already know I want the lowest possible numerator. I want the bottom of that to be as high as possible. So I'm going to want the highest possible F, subtract the lowest possible H. And only now do I substitute in these numbers. So the lowest possible C, 7.5, over twice the highest F, minus 3 times the lowest H. And now I can put that into my calculator. 7.5, use the fraction I should, 2 times 6.625 minus 3 times 1.15 equals, and I get the answer 0.7653 and so on, and it wants the answer correct to 3 decimal places, 0.65, and that is question 19 sorted. Question 20 now, complex algebra. That's what this looks like to me. Let's have a look. I've got k in terms of x and y. There it is. And I'm told what x is in terms of y. Well, I'm straight away thinking that if k equals x minus y, and if x equals 1 over 4y, then k equals 1 over 4y minus y. And I'm thinking I can simplify that further now. So k will be 1 over 4y minus, now I'm going to write this, which is y over 1. It's something over 4y. So I'm multiplying top and bottom by 4y. The top multiplied by 4y will be 4y squared. So what I've got here, my simplified version of k, is 1 minus 4y squared over 4y. So that's what k is equal to. Okay. Now I'm being asked to express 5k over x plus 2 in this form. I'm hoping to get an answer that looks like that. So let's start out by working out what 5k is going to be. So 5k will be 5 times k, and I know what k is. K is written here, isn't it? So that's going to be 5 times 1 minus 4y squared over 4y, which is going to be, multiply out that top bracket, shall I? 5 minus 20y squared over 4y. Okay, so that's 5k. Now I've got to express 5k divided by x plus 2. So let's work out what x plus 2 will look like. X plus 2 is x, which look, is 1 over 4y, plus 2. And again, let's simplify that. Write them both over 4y. 1 over 4y plus, now 2 is equal to 8y divided by 4y. So what I have here is I have 1 plus 8y all over 4y. Okay, now what am I being asked to do? I'm being asked to do 5k divided by x plus 2. So that's going to be 5k, which is 5 minus 20y squared over 4y. Copy that from there. Divided by x plus 2, which is 1 plus 8y over 4y. Copy that from there. Now look, I'm dividing fractions. So I'm going to have 5 minus 20y squared over 4y. I'm going to keep, change, flip. Keep, change, flip. Okay. So I'm going to end up with top times top. 4y multiplied by 5 minus 20y squared over 4y. Now look at that. Multiplied by 1 plus 8y. Divide both sides, divide top and bottom by 4y. Happy with that? Leaves me with 5 minus 20y squared over 1 plus 8y. Let's have a look at that. We've got to express this one here, in the form something minus something y squared over something plus something y. There we go, we've done it. And there is my solution to question 20. Question 21. Now, this looks like quite a complex area problem involving a circle and a square. We're definitely in the realms of sort of hard grade 7, grade 8, grade 9 questions here. If you want some more questions of this level, then leave me a comment in the description and I'll send you some links to my grade 7, 8 and 9 playlists. Right, let's have a look at this question. Now, we've got a square and a circle. The sides of the square are tangents to the circle, so it all fits in exactly. Now, this is the important sentence. We're going to be able to use this to write an equation. The total area of the shaded regions is 80 square centimeters. Work out the length of AC. Right, let's start by assuming or calling the radius r, which means that the sides of those squares, the sides of that square are 2r in length. So now we're going to use this because we're told the total area of the shaded region equals 80. So we're going to write an expression for the total area of the shaded regions. Now, the total area of the shaded regions now is the area of the square, 2r times 2r, minus the area of the circle, pi r squared. And that's what equals 80. And this equation now, we can solve this equation for r. So we're going to have 4r squared minus pi r squared equals 80. Now, how am I going to solve that equation? Well, I'm going to factorize so that I've got r squared times by 4 minus pi equals 80. Now I'm going to divide both sides by 4 minus pi to find r. R is the square root of 80 over 4 minus pi. Now if I put that into my calculator, 80 over 4 minus pi, right, that equals 93, square root that, and I get r is 9.65, and so on. So I'm being asked to work out the length of AC. Now that's the length from A down to C. So what I'm looking at here is I'm looking at this right angle triangle here. And I've got a hypotenuse, which is AC, and I've got AB and BC. Well, both of those lengths, AB and BC, are both 2r, aren't they? So I've times my r by 2. Both of those lengths are 19.3, and so on. And so what I'm going to do to find AC is I'm going to do the square root of 19.3 squared plus 19.3 ... squared. So I've got that whole number on my calculator. So I'm going to square it, press equals, times by 2 equals. And so I get AC is the square root of 745.5 and so on. So on my calculator, I'll square root that. Gives me an answer of 27.305 and so on for AC. And asked to give my answer to three significant figures, 27.3 centimeters. And that is my solution for 21. Question 22. Now in this question, we're giving a straight line, the equation of a straight line and the equation of a curve. And we're asked to find the coordinates of the points, plural, where the line and the curve intersect. So this is a question on solving quadratic simultaneous equations. We have to solve this pair of simultaneous equations, or this pair of equations simultaneously, and one of the equations is a quadratic. So we have a fixed way of doing this, and by the way, I've got question after question of these kind of questions on my YouTube channel. If you want a link to the films, leave me a comment, and of course I'll send you a link. What we're going to do is we're going to use this first equation to give us an expression either for x or for y. I'm going to minus y from both sides, which is going to tell me that x equals 5 minus y. And now I'm going to substitute that expression for x into the second equation in place of x. So the second equation was 2x squared plus 3y squared equals 210. So now instead of 2x squared, I'm going to write 2 times 5 minus y squared. 2 times 5 minus y times 5 minus y. Plus 3y squared equals 210. And now I can solve this equation to find out what y is. So 2 times, now I'm going to expand these two brackets here. 5 times 5 is 25 minus 5y minus 5y plus y squared. Close the square bracket. Copy down the 3y squared equals 210. Let's tidy up that square bracket. 25 minus 10y plus y squared. Close the square bracket. Copy down the plus 3y squared equals 210. This is just about doing one step at a time. Okay, and not messing up your algebra. I'm multiplying out this square bracket now. Generally, the minute I say don't mess up your algebra, I make an algebraic error. I'm okay so far. Right, let's tidy up the left-hand side. I've got 5y squareds minus 20y plus 50 equals 210. Now this is a quadratic equation, isn't it? I can solve it for y. I'm going to set it equal to 0 first, because that's the first step. So I'm subtracting 210 from both sides. Now, I could simply use the formula from this point, or I could try and factorize, but I'm going to take out the 5 first. In fact, I'm going to divide both sides by 5 to give me y squared minus 4y minus 32 equals 0. And now I'm going to see if I can't factorize it. If I can't factorize it, I'll use the formula. I can factorize it. I can already see that. We multiply to a minus 32, so we're going to have a plus and a minus. And I need to end up with minus 4, so I'm going to have minus 8 there and plus 4 there. Just make sure you're happy with that. So my solutions are that y could be minus 4 or 8. Now I found y could be minus 4 or 8. I need to find x. So I'm going to use this equation here to help me find x, because I know that x is 5 minus y. So in one of my cases, y is minus 4. So x would be 5 minus minus 4, 9. So that is going to be the point 9, comma, minus 4. X is 9, y is minus 4. And in my second case, I had y equaling 8. So x will be 5 minus 8. So x will be minus 3. So that's going to be the point minus 3, 8. X is minus 3. Y is 8. So my two solutions, my 2 points, where the line and the curve intersect, are the points 9 minus 4 and minus 3, 8. As I say, I've got many more examples of this. Lots of past questions walked through. So leave me a comment if you want me to send you a link. And that's question 22 done. Question 23, right, we are definitely in the realms of grade 8, grade 9 now. Perhaps you want to leave me a comment in the comments asking for my playlist or asking for some films made up of grade 9 questions. I've also got a film on all you need to know about indices for your Edexcel IGCSE Maths. Leave me a comment and I'll leave you the link. But in the meantime, let's have a look at this question here. Now we've got on the numerator 30 times 25 to the power of 2x plus 7. So we're going to write these as prime factors here. So I'm going to write 30 as a product of primes. Now I happen to know that it's 6 5, so I can take it from there. But of course you can use the fact button on your calculator. But 30 is simply 2 times 3, 6 times 5 times. Now we've got 25 to the power of something. Now 25 is 5 squared, so this is 5 squared to the power of 2x plus 7. Let's worry about that in a moment or two, but I can already see how I'm going to use the rules of indices there. Right, the square root of 180. Right, well that's going to be the square root of, and I'm going to use the fact button on my calculator to tell me that 180 is 2 squared times 3 squared times 5, so it's the square root of that, times, now the square root of 5, that's 5 to the half, so I've got 5 to the power of a half, raised to the power of 4x plus 9. Okay, I'm getting there. Now let's see what we can do to simplify this numerator here. I've got 2 times 3 times 5. Now I've got 5 squared raised to the power of 2x plus 7. So I'm going to multiply those powers. So that's going to be times 5 to the power of 4x plus 14. All over. Now, I'm working at this now, the square root of that. Well, that's going to be the square root of 2 squared, 2, times the square root of 3 squared, 3, times the square root of 5, 5 to the half, times by, now I'm looking at this. 5 to the power of a half raised to the power of 4x plus 9. So I'm going to multiply those powers. That's y to the power of 2x plus 4.5. Okay, now let's look at the top. I've got 2 times 3 times. I'm looking at this. 5 to the 1 times 5 to the 4x plus 14. Add those powers, that's 5 to the power of 4x plus 15, all over 2 times 3 times, now I'm looking at this, 5 to the power of a half times 5 to the power of 2x plus 4.5, add those powers, 5 to the power of 2x plus 5. Right, now look at that, can't I divide top and bottom by 2 and by 3? So aren't I left with 5 to the power of 4x plus 15 over 5 to the power of 2x plus 5? And doesn't that mean 5 to the power of 4x plus 15 divided by 5 to the power of 2x plus 5? And when I divide, I subtract the powers, right? So that's going to be 5 to the power of, I'm going to do this minus this. So that's going to be 5 to the power of 2x plus 10. Now let's have a look at the question. Simplify that. Give your answer in the form 5 to the power of something, where the something is an expression in terms of x. There you are, I've done it. 5 to the power of 2x plus 10. And that is question 23 sorted. Question 24. I can see straight away that this is a question about vectors. Now, vectors is a very common topic for the ends of IGCSE papers, and I've got a playlist which will help you out if you are preparing and wanting to get a top grade in your Edexcel IGCSE Maths. So leave me a comment, ask for a link to the vectors playlist if these are questions that you want to target. Right, let's have a look at 24 part A. All right, we've got a diagram, we've got a quadrilateral. Let's just check that each of these vectors is indeed labelled on the diagram. Okay, we've got to find A to C. find the vector AC. So if I was going from A to C, of course you might like to go straight up there, but I don't know anything about that movement. So I'm going to have to go from A to O, and then from O to B, and then from B to C. So from A to O, now that's from here to here, right? That's minus 4A. Then from O up to B, that's plus 3B. And then from B to C, that's 2A plus B. So there's the whole journey. So I'm going to simplify that to give me 4B minus 2A. And that is part A done. Okay, 24B, let's have a look. The point P lies on AC such that AP to PC is 3 to 2. AP, that's here, to PC, 3 to 2. So I'm going to label that 3 to 2. The point Q is such that OPQ, that must be over here, look. O to P to Q, OPQ, and BCQ, B to C to Q. Here we go. So that must be the point Q. The point Q is such that OPQ and BCQ are straight lines. Okay. Using a vector method, find O to Q in terms of A and B. Okay. Right, let's have a look. We're going to need to make our way from O to Q in two different routes. The first route I'm going to use is going to be I'm going to call the green route. And we're simply going to go from O to Q on that green road, which is already green. So I'm going to delete that extra green line. So my green route is going to be O to Q. And that's going to be O to P, but some multiple, isn't it, of O to P? I don't know what multiple it is. I'm going to call it, it's a bit more. Perhaps it's 2 O to P's. I'm not sure. I'm going to call it X O to P's. Okay. Now, my second route, which, because I've got this blue line already here, I'm going to call it the blue route. It's going to go from O to B and then across to Q. So my blue route, OQ, is going to be OB and then B to Q. Okay, right. Now let's have a look then. So my green route is going to be X times O to P. Now O to P is going to be, actually what, I'll go O to A, and then I'll add on A to P. So let's work out what that'll be. X times, well, O to A is 4A, plus A to P. Now A to P is 3/5 of the way from A to C. And I've already got A to C in part A, so that's going to be good. So that is X times 4A plus 3/5 times A to C. A to C is 4B minus 2A. So that is X times 4A plus 12 over 5B. They don't make it easy, do they? Minus 6 over 5A, which is going to be, I've got 4 minus 6 over 5A's. Now I know that we can do that in our heads, but I'm just going to use the calculator here. So that gives me 14 over 5. So I've got X times 14 over 5A plus 12 over 5B, which is 14 over 5 x a's plus 12 over 5 x b's. Okay, so that's my green root done. Okay, now my blue root. Now for the blue root, we said we were going to do O to B. Well, O to B is O to B, it's 3b, plus B to Q. Now B to Q, here we are, B to Q, is a multiple, I'm not sure what multiple, of B to C. That was me trying to make it clearer for you. That wasn't very helpful. So B to C is this bit here. B to Q, sorry, is that bit, which is a multiple of B to C. So what multiple? I don't know. Let's call it Y. Y, B, C, which is going to be 3b plus y. Now BC, I already know, it's 2a plus b. Right, so that is going to be 3b plus 2ya plus yb. So altogether, that is 3 plus, sorry, it is 3b plus yb plus 2ya. So how many b's is it altogether? It's 3 plus yb's, and how many a's? 2ya's. Now, here's the trick. You know how both the green and the blue are equal journeys? That means that they must have the same number of b's in them. So the number of b's in the green must equal the number of b's in the blue, and they must both have the same number of a's in them. So the number of a's in the green must equal the number of a's in the blue. So I can write two equations here. I can write 12 over 5x equals 3 plus y. That's the number of b's in the green equals the number of b's in the blue. And I can write 14 over 5x, the number of a's in the blue, equals 2y, the number of a's in the, the number of a's in the green equals the number of a's in the blue. And I can solve these equations simultaneously now. So what I'm going to do is I'm going to use this equation here to tell me that y is 14 over 10x. I've divided both sides by 2. So I'm going to substitute that into my top equation. 12 over 5x equals 3 plus y, so 3 plus 14 over 10x. I can solve this for x now. Let's multiply everything by 10. 24x equals 30 plus 14x. 10x equals 30. Look at that, x equals 3. So now I can find what y is. Y is 14 over 10 times 3, which is 1.4 times 3, isn't it? Which is 4.2. So now what's the question? The question is find OP in terms of A and B. So it doesn't matter which version. Sorry, the question is find OQ in terms of A and B. So it doesn't matter which version I use. Okay, I'm going to use the green version. So my green version was that OQ was equal to 14 over 5xa plus 12 over 5xb. And I know what x is, don't I? X is 3. So that's 14 over 5 times 3 a's plus 12 over 5 times 3 b's, which is 14 times 3, 42 over 5a plus 36 over 5b. And that is my solution to question 24. Question 25. Now, before we move into question 25, which, by the way, looks like transforming a trig curve to me, there's lots more to help you on the YouTube channel. So please leave me a comment if you want any links. Also, in the description of this film, you'll find the link you need to join my mailing list. And those on my mailing list, I send messages to when I publish something new or when I have a YouTube live coming up, that sort of thing. So do get yourself on my mailing list if you want to receive those messages, or get your mum or dad on my mailing list and then they'll get the messages, because quite often a parent is slightly better at reading their emails than one of you guys who's busy with your GCSEs. Right, question 25, transforming a trig curve. The diagram shows a sketch of the graph of y equals 2 sine x plus 60. Now I'm just looking at this. I can see that it's symmetrical about the x-axis, of course it is. And you know how a sine curve normally goes from 1 to minus 1. Because this is twice that, we know it must be going from 2 down to minus 2. Okay? Now, what's more, let's think about the normal sine curve, shall we? Perhaps we should have thought about this. Sort of started by drawing a normal sine curve. That would have made it easier, perhaps. Here's my normal sine curve. When I say normal sine curve, I just mean here's the sine curve. Now, sine curve goes here. Okay, it goes up as far as 1, doesn't it? Let's do 90, 180, 270, 360. Here it is. Here's my graph of y equals sine x. Oh, not very well drawn, but I'm trying my best. There we go. Now, we've already dealt with the fact that our curve is y equals 2 sine x. Now, that means it's going to double, so it's going to be up here, there, double down here, there we are. So there is the graph of y equals 2 sine x. So what have I got here? Because this maximum point here has shoved to the left, hasn't it? Ah, must have shoved to the left 60 degrees, mustn't it? Because remember, if it's in the bracket, it changes the x-coordinate going the wrong way. So this is obviously moved 60 degrees. Okay, so now it would be at 30, wouldn't it? So that is 30. So look at that. The point A is the point 30, 2. Okay, that must be 90. Okay, so 1, 2, 3, that must be 180. 1, 2, 3, that must be 270. That must be 300. So the point B is at 300, 0. Now, it won't surprise you to know that I've got a playlist full of examples of transforming graphs, which again, it's a key topic if you want to get one of those top grades. So maybe leave me a comment and ask me about that. Right, in a moment, I'll tell you all about the grade boundaries for this paper.
Mr Wright here, and well done for making it through to the end of the paper. In a moment, I'll show you the grade boundaries and I'll show you how to calculate what grade you would have got had you been sitting this paper or this set of papers. But first, if you found these video walkthroughs useful, please do hit like. It really helps the channel and it tells me that you have found the film useful, and it's good to have some positive feedback. Of course, if you want to see more of the same, do subscribe to the channel and then you'll get notifications every time I post something new. So, the grade boundaries. Well, here they are. And what you need to do is to add together your 2 marks on the 2 papers. Of course, both marks out of 100, so that gives you a total out of 200. And then you can use this table to read off what your grade would have been had you sat this set of papers. Leave me a comment, tell me how you've done, and good luck with your exams.